Hi, we meet again at the second part of the document properties and processing. We will continue with discussing the vector space model and the cluster-based model. Now we move on to vector space retrieval model. This is the second models that we are discussing today. In a vector space model, we represent the document as a point. So each document will be represented as a point in a vector space. Now we are, or you are actually very familiar with the vector space model. So let's consider that we have a two-dimensional space. Normally we call the x-axis and y-axis. And then we have a point P. Let's say the position of point P is has value axis is 5, and then the y coordinate is 2. So P is 5.2. So P is a point, but actually it consists of vectors. One is vector x, and the length is 5, and the other one is vector y, the component, and the length is 2. And it points the resultant of this vector points to the position of P in this two-dimensional vector space. Now the same thing with that is that each of our document is represented by term 1, term 2, term 3, term 4, and so on, like this one. So any document TI will be considered to consist of term 1, term 2, term 3, and so on until term number n. Okay. And since our documents are may not be of the same length and may not be of the same consist of the same terms, then any document which doesn't have a particular terms will have a weight of 0. Now the query is also represented in the same way to be considered as consisting of n terms. And if the query is much shorter than that and consists only of few terms, then the weight for any terms which does not appear on the query will be considered as 0. Okay, and the way we measure the similarity of any document I with the query QJ is represented in these equations. So we sum up from k equal 1, this is term number 1, to term number n, because here is n. And then it is simply a summation of tik multiplied by qjk. Tik is the term width, not the word, not the term itself, but the term width. And then qjk is also the query weight, term query weight. Okay, now the problem with the this measure is that the number is unbounded. So for that reason, then we use the cosine coefficient, where basically is the same expression as you see. This is the numerator of the expression of the equation is the same as before. The difference is that there is the denominator here, which is also the summation of the tik squared, and then multiplied by the summation of the qjk squared. So the value now is bounded between 0 to 1, and so it is called the cosine coefficient because the value is never greater or larger than 1. Now we will give you the example after this one. So the step that we have to do for processing document using the vector space retrieval model is first we eliminate stop words by consulting a stop list. So it's the same as before, and then we replace the all terms with similar meanings with a common word. So this is the model of the IR model, right? So followed by stemming the words, we remove the suffix, the infix, and also the prefix or the inflection. And then we count the stem frequencies in each document. So how many times a particular term appears on a document. Then we calculate term stem weight, term or stem weight. We call it stem because we already do some stemming for the word. If it is not stemmed, then you can use the calculate term weights. Okay, the next step is to create the document representation, which for this example, for this discussion topic, is a vector space model. And then the feature matching or similarity measurement. In this example, in the following example, we will use the cosine coefficient for this, and then we evaluate the performance of our method. Okay, so this is an example. Now, let's suppose you have 4 documents, then you have to find the term. Okay, for the assignment, you can find the term manually. It means that you read and then you tabulate. Okay, you might use Excel for this one. Okay, term number 1 is what is the term name. If you want to stem, then you could stem manually also with your mind. So for example, retrieval, then you know, okay, so the root word is retrieve. Okay, so let's suppose that for the 4 documents that we have, it consists of 1,000 terms. Okay, not all document have 1,000 terms. We will see this one. For example, document number 1 has T1, term number 1, and the number of terms, the number of occurrences is 5 here. Terms number 2 also 5 times appears on the on document 1. Term number 3 appears 5 times on document number 1, and terms number 4 appears 4 times, number 5 10 times, number 6 4 times, and so on. And term number 1,000 appears only 2 times on document 1. For document 2, it doesn't have term 1. So the weight is 0. So the term frequency is 0. So this is the table for the term frequency. Now document number 3 doesn't have term 1 also. So the frequency of the appearance of term 1 is also 0. Now, document number 3 doesn't have term number 3 also. Document number 4 doesn't have term number 1, and also it doesn't have term number 1,000. Okay, so now let's calculate the weight. So we generate the vector space representations from the frequency tabulation. So for document number 1, term number 1, the weight is calculated using this formula. Term and the frequency of term number 1 on document 1 is 5. So we write 5 here. And then multiplied by logarithm of m. This is the number of document. But m in our case is equal to 4 because we have only 4 documents. And DFG, okay, for term 1, it appears only on document number 1. So it doesn't appear on document number 2, document number 3, and document number 4, which means that DFG for term number 1 is 1. So the weight is 5 logarithm of 4 divided by 1, which is 4. Whatever the number of log 4. Okay. Okay, so then we calculate the weight for term number 2, still for document number 1. And the appearance is also 5. So we write 5 here, and logarithm of 4 divided by DFG. Unfortunately, all document has this term. It means that this term is not a good term to distinguishing any document. So finally, this logarithm is logarithm 4 divided by 4, which is logarithm 1, but logarithm 1 is 0. So for term 2, the weights are all 0 here. So it means that term 2 is actually can be dropped for this 4 document, but we leave it there because at later time there could be another document added to our corpus, and we have to update the the weight for our document representations. Now document number 3, term number 3 could also be calculated the same way, and the term frequency is 5, and then m is still 4, like before, but term 3 appears on 3 documents. So finally the weight is 5 multiplied by logarithm of 4 divided by 3. Okay, and so on. So you can fill up this table. For document number 2 is the same way. Okay, so based on what we have done before, then we have the term weight like this one. So this is the vector space model of our document in our system. So the upper table is exactly the same as before. I put it here again so that you can see the numbers. Now we want to match the query with the document which is on our system. So how to calculate the degree of matching? Let's suppose that we work only for query number 1. Now how do we calculate this one? Okay, first we calculate the denominator. So it is a summation from k equal 1 to n. In this case, n is 1000. So n is 1000 here. tik multiplied by qjk. So for query number 1, this one is multiplied by that one. Okay, this is an example only. Q1, the weight is I just given a random number 5, 3, 0, and so on. And then for the second term of the summation, we multiply that number with this number, and so on. Yeah. And then the denominator is for this one, it is a summation of k from 1 to n, the tik. So we square this thing individually and then add them up. And then for this part, okay, so this one is for this, and this one is for this. Okay, so now we get the value for s. Now then we calculate also Q1 and the similarity between Q1 and document number 2, Q1 and document number 3, Q1 and document number 4. Now remember that we don't calculate the similarity, the degree of similarity directly to the document, but to our document representation or to our features of that particular document. Okay, now this is the third model that we would like to discuss today, which is the cluster-based model. Okay, so we start with the cluster generations. Now let's suppose that we have a number of documents, of document representations. So as I said before, it is normally nice to represent this in a vector space model like the one we just discussed. And so that each document is a point in a multi-dimensional space. In our previous example, each document is a point in 1000 dimensional space. Now we use the agglomerative clustering process. Of course, you could use other clustering algorithm also. We will discuss other clustering algorithm next after the midterm exam. So each document is initially placed into a class by itself. Now let's suppose for what is this? For illustration, I have this document. I have only okay, I have only 4 documents. Okay, so the first step says that okay, let each document be a class by itself. So there are 4 classes. Okay. Like my drawing up here. Then next time we say then two most similar documents based on the pairwise similarities are combined into a cluster. So now we have to let's say this is number 1, this is number 2, this is number 3, and this is number 4. Step number 2 says that well, we have to measure the similarities between document number 1 and number 2, number 1 and number 3, number 1 and number 4, and then number 2 to number 3, and 2 to number 4, and then document 3 to number 4. And then we find the most similar pair. Okay, let's suppose that the most similar pair is document number 2 and number 3. So then we combine this one to become a single cluster. Normally, it is represented by the cluster center, the mean of the two documents, which is, let's suppose here. So in this case, we have only a document in two-dimensional space. It has only term 1 and term 2. Okay, now we continue with the next step. Similarities between the newly formed cluster, this one, and other documents are calculated. Then again, the most similar documents, also including the cluster, are combined into a new cluster. Okay, in this case, the next most similar thing I think is between 2 and 4, and so we combine this into a cluster. So now we have two clusters. And then the next step is we repeat again. Combining process continue until all documents are grouped into a supercluster. Okay. In this case, because we have only two clusters, then the next step, of course, is measuring the difference between the similarities between the two. And since only the two, then we don't actually have to measure the similarity. The next one would be combining these two, and the cluster center is represented probably on this position. And so our cluster is formed. Now we have to generate our cluster, and then the cluster center is represented by the cluster is represented by the cluster center. Okay, so cluster generation is complete, and now we are continuing with retrieval. So how do we retrieve a document? Now I have to draw the previous example. We have here, and we have there and there. This one is one cluster, that one is another cluster, and then the root cluster is represented by that X. Okay. I will draw another X here as the cluster center of the first cluster, and then there is another cluster center there. Okay, so how do we retrieve the document? It is said that the cluster with the highest similarity to the query vector is identified. Sorry. So let's suppose we have a query, and our query in our vector space might be okay, I will put it here. This is the query. So we have to identify which one is closer. I think the cluster on the left would be closer to the query. So I will write here. This is the query. Okay, so all documents in the cluster are retrieved. So which document? The document on the left. There are, I think this one is document number 1 and document number 4. So we retrieve document number 1 and number 4 because the cluster is closer to the query. Then query vector is compared with each document vector in the cluster, and only the most similar documents are retrieved. So now the query vector, each document, this one, the query is now measured the similarity with document number 1 and number 4. Now we found out that document number 4 is the closest to the query. So now document number 4 is retrieved. Now why should we use the cluster-based model? Okay, let's suppose that we don't use the cluster-based model. How many computation we have to, how many similarity measurements we have to carry out? Without clustering, we would measure the similarity of the query with document number 1, 2, 3, and 4. So 4 times. Okay, during the retrieval. It's not on the building of the document or building of the corpus. With cluster-based model, we have only 2 clusters in this case. We measure the similarity 3 times. One is measuring the query with 2 clusters. The 2 clusters, okay, so 2. And then we retrieve document on the query, on the cluster, which consists also 2 documents. And so we have to calculate another 2 similarity between the query and document number 1 and document number 2. Well, it doesn't make any difference, right? Clustering and without clustering, we have to calculate 4 times. Well, that is for very small clustering model. Now, let's suppose we have 1,000. We have 1,000 document. Now, suppose we have 1,000 document like this one. Okay. Now, it consists of 10 clusters. And each cluster consists of 100 documents. So we just divided the 1,000 into 10 clusters evenly. Okay, without cluster-based model, then for each query, we have to calculate 1,000 times. The query with document number 1, query with document number 2, and so on. So 1,000 times. With the cluster-based model, we will calculate 10 times. Why? Because the query has to be, the distance between the query and the cluster has to be calculated, and it needs 10 times. And then inside the cluster, the selected cluster, there are 100 documents, and so we have to calculate also 100 times. So with the clustering, then we need only to calculate 110 times, whereas without clustering, we have to calculate 1,000 times. Okay, so that's a big saving, computational saving. It's almost 10 times faster. Okay, so the last part would be the performance evaluations. Okay, we discuss only recall and precision. So recall says this is the ratio between the number of relevant items retrieved and the total number of relevant items in the database. And precision is the ratio between the number of relevant items retrieved. So the enumerator is the same, that is the number of relevant items retrieved. But the denominator is the total number of retrieved items. Okay. We will discuss this. Normally for our system, we have a performance like this one, like A or B. Now, which one is better, A or B? That's the questions. Okay, so let's take an example like this one. Okay, in this example, we have item in database is 1000. So we have 1000 items or 1000 documents in the database. And then we have 10 items relevant to a particular query. Okay. So there is a query and we have 10 items, 10 documents, which is relevant to that query. We know that this one is known. Now, let's suppose that this is the sequence of the retrieved item. So the first one is relevant. So this is a human judgment. Okay, document number 1 retrieved, it is relevant. Document number 2 also relevant. Document number 3, unfortunately, it is not relevant. Document number 4 is also not relevant. Number 5 and 6 are relevant. Number 7 and 8 are not relevant. Number 9 relevant. Number 10 not relevant. Number 11 and 12 are relevant. 13 and 14 are not relevant. And number 15 are relevant. Is relevant. Now, let's suppose that we make a table like the one on the right here. So when we have one document retrieved, the document is relevant. So the recall, remember the definition, the recall is calculated as the number of relevant items retrieved divided by the total number of relevant document in the system. So the denominator in this case, in this particular query, is always 10 because there are 10 items relevant to a particular query, to this query. Okay, so we got this as the recall. What about the precision? Precision is measured as the number of relevant items retrieved divided by the number of documents retrieved. Since the number of document retrieved is only 1, then the precision is 1 divided by 1. Okay, so if the document retrieved is 5, for example, here, then the precision is 3/5. So it means that we limit this one here. There are 3 relevant items and 2 not relevant items. So the precision is 3/5, which is about 60%. Now let's suppose we compute again on the 10th after the system retrieve 10 documents. What happened? Okay, the total number of documents retrieved is 10. Of those 10 documents, only 5 are relevant. So the precision is 5, and the recall, the precision is 5/10. And from the recall, we find that the relevant items are 5 also, but the denominator is 10 because there are actually 10 documents inside, and so on. Okay, so if we plot this recall versus the precision, then we will obtain a graph similar to these things. Okay, what we can see here is that the precision on this particular example is increasing on that direction, and for the recall is on the other direction. So it means that on the graph on the lower left here, when the precision, when we choose to have a higher precision, then the recall unfortunately is low. So for example, this point, if we force to have a recall very high, unfortunately the precision is low. That is typical trade-off of our method's performance. Okay, just to consider for your mind. Now let's consider other kind of applications. Let's say plagiarism detection. This is somehow related to your assignment, which will be described just after this. And then, so what is plagiarism detection? We try to calculate the degree of similarity between newer document with older ones. Now it's really depends on how we measure. So one plagiarism detection method and other plagiarism detection method doesn't always give the same score, because they have a different scoring system. Okay, then other application is the document clustering. We group documents into a particular group. For example, from the internet, we could collect the business news, sport news, political news, and so on. We could also do a classification. Classification is not grouping, but determining a document into an existing group. Let's say we have a document which we don't know. We have a new document from the internet, and we want to place this one either on political news or sport news or business news. So we extract features, and then we finally classify them. Of course, normally it is classified onto the cluster which is most similar to that particular document. Okay, so now this is the last page, is your assignment. It is a lightweight assignment. If you do this completely on an Excel or a similar product, then you will be given a maximum of 80% marks, or 80, not 100. But if you do the way it is required, and then you might get 100. So what you have to do first is you have to obtain 3 abstracts, not many, just 3 abstracts from this is the journal website of our journals, website of our journals, the journal ugm.ac.id/ijccs, or the second journal is the journal.ugm.ac.id/ijaeis. Now the second journal here is in Bahasa Indonesia, and the first one is in Bahasa Inggris. So it is up to you whether you want to process the Indonesian document or English document. Remember, only the abstract. So you have to cut the abstract. Now you parse by yourself. It means that you are reading the document, and then you make a table. And that's why you can use Excel to help you to make the table. Word number 1 saved in column number 1, and it appears word number 2 in column number 2, and it appears 1, and so on. And then you can update the number of occurrence of that particular term appears on this document. Now do this for the 3 document. So basically you have a table of 4 rows. First row is the terms, second row, third row, fourth row is the frequency, appearance of that particular terms, and the number of columns depends on the number of terms in that abstracts. So then this is the programming part. Write a program to read your representation, then measures the similarity among the 3 documents. So it means that you measure the similarity between document 1 and 2, this one, and then since you have only 3 documents, you measure also the similarity between document 1 and 3 and also document 2 and 3. So you measure 3 similarities. Yeah, based on their TF-IDF weighting scheme. You can calculate the weighting scheme also using the Excel. Well, I'm sorry, I'm not quite sure if Excel has a logarithm function, but if it has, then you can do so. Okay, but if you do that one, then it means that you will also compute the coefficient similarity using the Excel, and your mark will be maximum of 80%. So the report is just like before. Check at the previous assignment what the report format is required. It consists of a cover, an introduction, and so on. And since this is a lightweight assignments, then the due date is 1 week. So it is 1 week from now. Okay, so that's all for today, and thank you for your attention. Don't forget your assignment.